Hello, very good evening, my dear students. How you all are doing? Hopefully, you all are doing fabulously fine. So today I'm back on YouTube live platform with yet another session on Unacademy. Okay, Unacademy YouTube live platform, and this is my third session on previous year questions on electric field and Coulomb's law, right? So obviously in this particular session, I will be focusing on few more interesting problems on this particular part. Hopefully my previous two sessions you all enjoyed very well. So now let me just move on to the discussion part of it. Now over here, my name is Uttam Kumar Umarji. I'm an MTech graduate. Presently, I'm a verified Unacademy educator. I'm having a total of 19 years of experience, and I have taught to J Advanced and J Main Physics for closely about 19 years, 19 plus years actually, at various locations like Delhi, Kota, Bangalore, and almost all across India. I've taught. Then I've taught closely to 10,000 plus students till date. Okay, and currently working at Prarthana PU College at Hubli in Karnataka, and this is my fifth month on Unacademy, my dear students. Now that is where like I'm planning to make you people go through my knowledge filled sessions. Okay, and my endeavor towards the student was always to deliver the knowledge. That was my main endeavor. Okay, now let me just move on to one more important thing regarding Unacademy Plus subscription. Okay, now you must be wondering like now the examinations are nearing by, and most of you are in that state of say tension filled preparation mode, is it not? Now, in this scenario, you would be searching for certain professional coaching apps online. Okay, so you might be looking forward to some of the very interesting online platforms. Now, amongst them, right now in India, Unacademy happens to be one of the largest provider of live education. Okay, and as a part of this live education, we have one more interesting application of Unacademy, that is called as Unacademy Plus subscription. Okay, now this session what you are observing, this is totally free of cost. Now this is a free session. Okay, on YouTube what you are watching right now. Okay, but in addition to this, suppose you want to go through a very beautifully planned, highly interactive sessions, okay, which would be announced to you, say suppose, well in advance, then you will definitely like to go ahead and have a look at this, is it not? So hence this is the best answer to this particular thing is Unacademy Plus subscription. Okay, and Unacademy Plus subscription comes with various benefits. Now what kind of benefits? Now why you have to go ahead with Unacademy Plus subscription? Now if you are planning for plus subscription, look at this. We have 20 plus top educators, 10 plus batches are there. There are 250 plus courses. Then we have 2000 plus lessons. Okay, and many more lessons are getting added day in and day out, my dear friends. Okay, and by the virtue of this, we can say that what benefit we can get out of it. Now, benefits, if we just talk about, first and foremost thing, we will have a premium content at a very much affordable price. Now, pricing, I will get back to that pricing a bit later. But right now, you should remember that Unacademy Plus subscription is highly economic. Okay, and here we have a premium content at a very much affordable price. Now we have pricing as much as down as something like about 500 rupee a month. Imagine, look at this pricing. Okay, then we have a structured live courses with dedicated live doubt clarification sessions. After every course there will be a doubt clarification session. Then quizzes are conducted at regular intervals for self analysis, my dear friends. Then there are batches for complete preparation, my dear students. Then we have test series containing daily practice papers, full length mocks, everything with analysis. Okay, so I can say one single subscription for unlimited access. Now that is Unacademy Plus subscription, my dear students. Okay, so all in all, overall, in general, I can say everything under single plus subscription, right? Then let me just go to the pricing now. Okay, now if at all you would like to take a look at the pricing, you would be surprised. See here, we have a 1 month course. 1 month plan comes with 1500 rupee per month. Okay, so suppose you want to take only 1 month, go ahead with 1500 rupee for 1 month. Okay, then we have a 3 month plan. Now this 3 month plan comes with 3750 for 3 months. Now, over here, you have one more thing, like you can avail an EMI facility also. Okay, so that EMI works out to be 1250 per month. Now, if you just consider 3750 divided by 3, it will be exactly equal to 1250. So that means this is 0% EMI. Okay, then we have nextly a 6 months plan. Okay, 6 months plan comes with a pricing of 6000 rupee. Okay, look at this, 6 months 6000 rupee. Obviously you would be paying 1000 rupee a month. Okay, and you can avail again 0% EMI with 1000 rupee per month. Okay, then we have, this is the recommended one, I will recommend this for you. Then we have a 12-month plan. Now this 12-month plan, obviously it comes out with a pricing of 8250 for 12 months. Okay, it comes with an EMI of 687 rupee per month. Okay, then we have 24-month plan. 24-month plan comes with 12,000 rupee for 24 months. Okay, now over here it is obviously 500 rupee a month, we can say. Simply 24-month 12,000. So 12,000 divided by 24 is obviously 500 rupee. So imagine 500 rupee a month and EMI for 2 long year. Definitely it is the plan that you can ask if you are in PUC first year or class 11th. Okay, now suppose you want an additional payoff off on all any of these subscriptions. Use UTTAMLIVE as your referral code and get 10% off. Okay, so this is what I would like to give to you as a gift from your teacher. Okay, Aditi, very good evening, welcome to the session. Now let me move on to the questions now. Okay, in the past session, I had covered questions up to number 20, right? So now let me move on to 21st question now. The force between two charges 0.06 meter apart is 5 Newton. If each charge is moved towards the other by 0.01 meter, then the force between them will become, okay? Now, initially, the two charges are how much distance apart? 0.06 meter apart. Then force is how much? 5 Newton. When each charge, if it is moved towards the other by 0.01 meter. Okay, so here R1 is 0.06. R2 will be equal to what? 0.06 minus 0.02. Right? So that is what we are expecting here. So hence I can say F is inversely proportional to R square. This is the fact I know, right? Since F is inversely proportional to R square, I can write F1 by F2 is equal to R2 square by R1 square, right? So accordingly, F1 is 5 here, F2, I'll keep it as it is unknown. Then R2 can be calculated as how much? 0.06 minus 0.02, that should be 0.04. Now 0.04 divided by 0.06, I can write it as 4 by 6, which is nothing but 2 by 3. 2 by 3 whole square will be 4 by 9. So hence F2 will be equal to what? 5 into 9 by 4. So thus I'll get this as 11.25 Newton. Okay, 5 into 9 is 45. 45 by 4 is 11.25 Newton. Now this is the answer that we are supposed to mark. Okay, hopefully it is clear, my dear students. Now let me move on to next question, that is 22nd question. Now the 22nd question, it reads as two charged spheres separated at a distance small d exert a force capital F on each other. If they are immersed in a liquid of dielectric constant 2, then what is the force? We should calculate that. Okay. Now over here in air the force is F. Okay. And when these charged spheres are immersed in a liquid of dielectric constant 2, then very comfortably we can write this as F is inversely proportional to dielectric constant. So thus I can say F medium by F air is equal to dielectric constant of air divided by dielectric constant of the medium. Now dielectric constant of air is 1 and dielectric constant of the medium is K. So hence I'll write it as 1 by 2, and 1 by 2 happens to be F medium by F air. So therefore F medium will be equal to how much? F air by 2. Now F air, that is force in between the two spheres in air, is given as F. So hence I can write this as F by 2 here. Okay. So hence F medium will be equal to F by 2. Now let me just move on to the next question now. 2-point charges plus 3 microcoulomb plus 8 microcoulomb repel each other with a force of 40 Newton. Okay. If a charge of 5 microcoulomb minus 5 microcoulomb is added to each of them, then the force between them will become simple. Now over here we'll consider for the second case. Now new charge will be equal to what? Initially the charge is plus 3, right? So as you can notice here, plus 3 and plus 8, then minus 5 is added. So accordingly I am writing this as new charges will be what? Q1 will be equal to 3 minus 5, that should be minus 2 microcoulomb, and Q2 will be equal to Q2 dash will be equal to what? 8 minus 5, that is plus 3, right? So accordingly in the next step I'll write F is directly proportional to product of the charges. Now product of charges Q1 Q2. So hence I can write this as F by F dash is equal to Q1 Q2 by Q1 dash into Q2 dash. So accordingly I can write this as 40 divided by F dash is equal to 3 into 8 initial charges, 3 into 8 divided by minus 2 into 3. So thus I'll get this as what? 3 cancels off, 2 ones are 2 fours are, so we'll get 40 by F dash is equal to 4. Therefore F dash will be equal to 40 divided by minus 4. So that would be minus 10 Newton attractive. Okay, because we have minus 10 Newton. So obviously, since force is negative, this must be an attractive force. Okay. Next, 24th question. Electric charges of 1 microcoulomb, minus 1 microcoulomb and 2 microcoulomb are placed in air at the corners A, B and C respectively of an equilateral triangle ABC having length of each side 10 centimeter. The resultant force on the charge at C is. Now, look at the options. Remember them. Okay. Now, let me just consider as per the situation goes. 1 microcoulomb, minus 1 microcoulomb and 2 microcoulomb are placed in air at the corners A, B and C of an equilateral triangle ABC. So accordingly, I'll construct the equilateral triangle here. Okay. At A we have 1 microcoulomb, at B we have minus 1 microcoulomb, at C we have plus 2 microcoulomb. So now force on C due to charge at A is obviously Fa here, right? And we know that charge at C and charge at A, both of them are positive. So for that reason, the direction of the force, we can comfortably see that it is outward because both of them will repel here. So hence this is the repulsion that we can consider. So hence I am showing an arrow away from C like this. Okay. Now after this we have charge at C as plus 2 microcoulomb, charge at B as minus 1 microcoulomb. This clearly indicates that the two charges will attract each other. So hence the force FB will be towards charge at B. Okay. Now these are the directions, and since it is an equilateral triangle, angle between FA and FB will be in the exterior angle at C. Exterior angle of equilateral triangle is 120 degree. So that is the angle between two forces. Now, hence, Fa is equal to force on C due to charge placed at A. Okay, that can be calculated as 1 by 4 pi epsilon naught, which is 9 into 10 raised to 9 into 10 raised to minus 6, that is 1 microcoulomb, into 2 into 10 raised to minus 6, that is 2 microcoulomb, divided by distance is 10 centimeters. So I'll write this as 10 into 10 raised to minus 2 whole square. Okay. So accordingly, we'll get this as 1.8 Newton. Okay. Similarly now, FB. FB is force on C due to charge placed at B. Now over here, we can again get the value as magnitude as how much? 1.8 Newton here. Is it not, dear students? Okay. So accordingly, net force on C will be equal to, I can calculate net force as F net is equal to square root of Fa square plus Fb square plus 2 Fa Fb cos 120 degree, that is equal to 1.8 Newton here. Okay. So thus 1.8 Newton happens to be our answer here. Okay. Now let me just move on to our next question quickly. 25th question. Two copper balls, each weighing 10 gram, are kept in air 10 centimeter apart. If one electron from every 10 raised to 6 atoms is transferred from one ball to the other, the Coulomb force between them is. Now, atomic weight of copper is given as 63.5. Okay. Now, this problem, how we can address? Now, let us see now. Now, this is the situation. One electron is shifted from A to B. Suppose we consider like that. Okay. Now let me just go back to the problem quickly. So it is given that one electron from every 10 raised to 6 atoms is transferred from one ball to other. So accordingly, I am considering one such electron being transferred from A to B. Now, what is the distance here? 10 centimeter in between the two balls. Okay. So accordingly, number of atoms in the given mass we will calculate firstly. Okay. So that I can write it as 10 divided by 63.5 into Avogadro number. Okay, so this will work out to be around 9.48 into 10 raised to 22. Okay, then we have transfer of electron between the balls. We can calculate it as every 10 raised to 6 atom there is one electron which is being transferred. So hence we'll divide this total number of atoms by how much? 10 raised to minus 6. We're dividing it. Okay, so accordingly I'll get this as 9.48 into 10 raised to 16. Okay, so that is the answer that we can that is the value amount of number of electrons which are transferred between the two balls. Now hence magnitude of charge gained by each ball will be Q equal to 9.48 into 10 raised to 16 into 1.6 into 10 raised to minus 19. So accordingly, I'll get this as 0.015 Coulomb. Right. Then force of attraction between the balls hence can be calculated as K into Q square by R square here. Now R is 10 centimeter, that is 0.1, and Q is 0.015, right? So accordingly I'll write this as 9 into 10 raised to 9 divided by into 0.015 divided by zero point 0.1 whole square. Okay, so finally we'll get the answer as 2 into 10 raised to 8 Newton. Now this is the value that we are expecting here. Now let me just move on to 26th question now. Two particles of equal mass m and charge q are placed at a distance of 16 centimeter. They do not experience any force. The value of q by m is. Okay. Since they are not going to experience any force, obviously gravitational force must be equal to electrostatic force, right? So accordingly, gravitational force I'll write it as G m into m divided by r square, okay, equal to electrostatic force will be 1 by 4 pi epsilon naught into q square by r square. Now here r is how much? 16 centimeters, so 16 into 10 raised to minus 2 whole square. Now this can be cancelled off here readily, right? Thus I can very easily find q by m ratio from this. Now q square by m square I'll calculate, then take the square root of it. It works out to be root of 4 pi epsilon naught into g. Now this is the value, my dear students. Okay, hopefully it is clear. Now let me move on to the next question, that is question number 27 here. A solid conducting sphere of radius a has a net positive charge of 2q. A conducting spherical shell of inner radius b and outer radius c is concentric with the solid sphere and has a net charge minus q. The surface charge density on the inner and outer surfaces of the spherical shell will be. Okay. Now, inner and outer surface, that means they are asking us to find surface charge density here as well as here. This is inner surface, this is outer surface. Okay, fine. According to the situation, if you just observe here, we know that the charge on the inner sphere is how much? Plus 2q. Hence it will induce a charge of minus 2q on the inner surface of the spherical shell. Okay, then we have net charge equal to how much? Now here we have charge distribution of minus q on the outer surface. So obviously it will be minus q plus 2q here. That will be equal to what? Q, right? So thus I can write surface charge density sigma will be equal to charge by surface area. So hence sigma inner can be written as 2q by 4 pi b square, because we know that surface area of the sphere is 4 pi r square. Here for inner spherical shell, radius is how much? Inner surface, inner radius is b. Okay, and for spherical shell outside, outer radius is c here. So hence sigma outer will be equal to q by 4 pi c square. Okay, now these are the two values that we are expecting here. Now let me move on to question number 28 quickly. A charge q is placed at the center of the line joining two equal charges, capital Q. The system of three charges will be in equilibrium if small q is equal to, okay. Now over here I can write this as this diagram. I can draw it like this, okay. At A, charge QA is Q here, at B charge QB is Q, and at C we have charge small q. I'll consider the distances as x1 and x2 in between A and C, and then in between B and C it is x2, and net distance is x here, okay. Now because of force provided by sphere A, charge at A on B, I'll take it as FA here. Similarly, FC is attractive, so it is written in the opposite direction like this. Okay. Now, suppose the following figure, equilibrium of charge B is considered. In that case, for its equilibrium, we'll take it as FA is equal to FC. Okay, so hence FA is what? 1 by 4 pi epsilon naught into q square by 4x square, that is FA. Then FC will be 1 by 4 pi epsilon naught small q capital Q by x square. Okay, so from this I can comfortably write this as how much? Q is equal to minus q by 4 minus capital Q by 4. Okay, so this is the value that we are supposed to write. Now let me just take a look at 29th question quickly. Figure shows the electric lines of force emerging from a charged body. If the electric field at A and B are EA and EB respectively, and if the displacement between A and B is small r, okay, then very clearly, now if you just observe this charge electric field line density here, so you can see that first of all this is non-uniform field, okay, because each of these electric field lines are non-parallel, okay. So for that reason, and we see that the field line density is more at A and less at B. At B they are more widespread, whereas at A they are more closer to each other, so field line density is large here. So we can say that electric field at A is greater than electric field at B. So hence I'll go with option A here. Okay. So with this note, my dear students, I'm closing my discussion for the day. Today's discussion is the final part of frequently asked questions or previous year questions on electrostatics, electrostatic charge and field. I'll be coming back with electrostatic potential part a bit later. Okay, right now we will consider this as our concluding part of discussion on electric field and charge previous year questions. Okay, so I will see you back in my next session. Thank you one and all. Have a wonderful time. Bye then.